Alright class, in this video we're going to go over the photoelectric effect. Photo has to do with light and electric has to do with electricity. We're going to see how light is a form of energy. Now there is a particle-like behavior of light, like molecules and atoms. If light of a sufficient energy falls on a metal, electrons are emitted or released from its surface, or electric current will flow. This effect was used in early photocells, like a light-activated electric switch, very similar to how a solar battery, solar cells work in calculators. Now, the photoelectric effect essentially says if you shoot electrons of different colors, remember different colors have different frequencies and wavelengths, into a metal, remember metals help conduct electricity, depending on the type of color you have, it'll have a certain amount of energy, and that will either make a current or not. Red electrons don't have the minimum amount of energy, but as the energy increases, your kinetic energy actually increases as well. So if you go from red to green to blue, violet, and so on, your violet will actually have the most amount of energy. So if a photon does not have the minimum amount of energy required, no electron will be emitted. It just gets absorbed by the metal. One electron will only be emitted for each photon of light. So the more light you shine, the more photons will be released. Also, the higher the energy or frequency of your photon, the higher the kinetic energy of your electron. So your main equation you use is energy is equal to Planck's constant times the frequency of light. The bigger the frequency, the more waves per second of the color of light, the more energy you have. Now what happens if you increase the brightness of the light? That will just mean more photons get released. The energy, kinetic energy, will be the same. More photons will eject more electrons. Your kinetic energy of each is the same. So in dim light, I have a small amount of kinetic energy. In bright light, with more photons released, I'll have more particles of kinetic energy at the same energy depending on the color of light. Now, some useful applications of the photoelectric effect. It was found in the late 1800s. A glass tube filled with gas, say hydrogen, would glow when you have a high voltage applied to the ends of the tube. And that's because the electrons get to an excited state. So we're essentially working backwards, where if you create a current, it could actually make colors of light get emitted. Niels Bohr, he actually worked with Rutherford, extended the idea of having electrons move in distinct energy levels. So here, electrons can only exist in specific distances near the nucleus. Okay? Large radii mean higher energy for the electron. So remember, electrons are negatively charged particles. The protons are positively charged. So they want to get together, opposites attract. But the further away they are, the more energy needed in order to make that occur. Now if a photon of exactly the right energy strikes an atom, the electron will absorb the photon's energy taken in and jumps to a higher energy level. So for example, maybe I have an electron in the first energy level. So for example, let's say I have an electron in the first energy level, and then I give it green light. It might jump to the third energy level. There is no in between. It can't go over here, over here. It goes in distinct energy levels. However, the situation is unstable. The electron will fall back to its original energy level, giving off a photon of light. The photon is regenerated. So this is actually how they make fireworks work. If you take magnesium and you light it up into a firework, it actually releases a green color of light. That's because the electron went in a distinct energy level. So essentially all this means is light has a dual nature. It acts like a particle and a wave. It's wave-like because it reflects, it bounces, it refracts, it goes through. It also has constructive destructive interference. Two waves in the same direction will add up. They're an opposite, they subtract. They also could act particle-like in the photoelectric effect. It actually releases a photon bouncing off just like a normal particle would. Also, the atomic spectra having different colors of light get released. Alright class, so that's just a quick overview of the photoelectric effect. You also want to watch the video on nuclear chemistry. That'll be on your next test. If you have any questions, leave a comment down below or shoot me a message.